Find f such that the second derivative of f with respect to x is 6x, f of 0 equals 1, and f of 2 equals 5. So we're given the second derivative, and we need to figure out the function. So we're going to have to antidifferentiate twice. To find the first derivative, we antidifferentiate once. The antiderivative of x is x squared over 2. And when we take that 6 and divide it by 2, we get 3, plus a constant. Can't figure out what that constant is yet because we're not told anything about the first derivative. We're only told things about the function. So what we can do from here is antidifferentiate another time to get to that function. The antiderivative of 3x squared is x cubed, because the derivative of x cubed is 3x squared. And then we've got plus cx and plus d. And we need to figure out what the values of c and d are. We've got two pieces of information, and usually plugging in 0 is a little bit more helpful. If we plugged in 2 for x, then we would have an equation that has c and d in it. But if we plug in 0 first, that's going to get rid of the c, because we've got c times 0 is 0. And that works just a little bit better. So let's do that. Our f of 0 is equal to 0 plus 0 plus d. And we know that f of 0 was 1. So that tells us that d is 1. So our function is going to be x cubed plus cx plus 1. Now we can plug in 2 for x, and that'll help us figure out what c is. F of 2 is going to be 2 squared, which is 4, plus 2c plus 1. And we know that that is equal to 5, because we're told f of 2 is 5. Now on the left-hand side, 4 plus 1 is 5. So we have 5 plus 2c equals 5. If we subtract 5 from both sides, 2c is 0. Divide by 2, c is 0. So that constant's actually worth 0, equal to 0. And so that tells us that our f of x is just going to be x cubed plus 1, because 0 times x is just 0. That term goes away. And so we've got our function x cubed plus 1.